Okay, 20-1, this is going to be our last lesson of trigonometry. I'm sorry I can't be there, but you guys are going to rock it, and I just know that. So on Thursday, we started talking about the sine law. Okay, when we're working with sine law, if we kind of look back at this one, this is when we have the complete pair. Okay, so that means that if we have a side length, okay, so let's say we have our G, that means that the complete pair, whatever is going to be opposite from that, okay, this is one pair, and then the other pair means that even if I'm looking for it, this one I was looking for H, and I had that kind of opposite angle with it at that point. Okay, so you have that pair. Okay, angle with the side length, angle with the side length. Okay, you are going to always be given what that sine law is. It's going to say this. Anything that is lowercase, remember, this is going to be the side length. Okay, and then this is going to be the angle. Okay, just in case you forgot that. So the sine law is when we have two complete pairs, we're always going to be looking for that side. Now, when we're dealing with cosine law, okay, this is just for a different type of triangle. So it says here, okay, so it's going to be a triangle that doesn't have a complete pair. So it says draw an oblique triangle. So that means all three sides are going to be different sizes, okay, with three pieces of information, but we wouldn't be able to use the sine law to use. So you can pause this video now. I'm going to give you a second to try to draw a triangle with three pieces of information, okay, and then make up some numbers, and then, but that you wouldn't be able to use the sine law for. Okay, go ahead. Okay, so what some of your triangles were. So I'm going to draw an oblique triangle. This is going to be my attempt at one. It's not a right angle triangle. Okay, so I have angle A, I have angle B up here, I have angle C down here. Okay, I'm going to say that I have this angle. Let's go say that this one's going to be 58%. I'm going to say that I have like A to C side length, so that's going to be 11.3 centimeters. I'm just making up these numbers. And then I have A to B, so I'll say that this one's 9.1 centimeters. Okay, so this would be a triangle that I wouldn't be able to solve with sine law, okay, because I don't have pairs. If I look here, this is going to be one angle, and the pair would be the one opposite to it, and I don't have this side. Okay, maybe if I was looking for that side, that would mean that I would have to have at least this angle here, which would be B, that maybe then I could connect with this one, but I don't have that angle. And same thing here with C, I don't have this angle that connects to this side length. Okay, so I wouldn't be able to use sine law to solve for this. So this is two sides and one angle that aren't pairs. Okay, or another type of triangle. Sorry, I'm just going to write this so we know it. So it's going to be two sides. And we're going to say this is an included angle. Okay, and then there's another type of option that some of you might have drawn. Okay, an oblique. Let's see what my triangle is going to look like. Okay, this is my oblique triangle looking really weird. Okay, so I'm going to say this is A, this is B, this is C. Okay, three pieces of information. Okay, I'm going to say that this is, making up my numbers, 3.4 centimeters. I'm going to do A to C. I'm going to say this one is 4.1 centimeters. And what if I had another side length? What if this one was 2.8 centimeters? That's three pieces of information. I wouldn't be able to solve this with sine law because I have no angles there. So then this type would be three sides, okay, no angles. Okay, so these are the two different times that I'm going to try and use sine or cosine law. You're either going to have two sides and you're going to have an included angle, but they're not going to be pairs, or you're going to have three sides and no angles. Okay, so what is the cosine law then? Okay, let's go over that. I'm going to just move it on over here. You guys can do it any side. You guys will be given the sine law or cosine law and sine law on your pieces, but this is kind of where I'm going to write it. So I'm going to write cosine law on the side. You guys can write it above or below or get a new piece of paper to your point. There's going to be two different pieces. Okay, so it's either going to be a squared is equal to b squared plus c squared minus 2bc all times cos of a. Okay, this is one part of our cosine law. Okay, this is when we're dealing with your sides. Or there's the other part where you're maybe looking for your angles, and if we rearrange this around and I get cos of A is equal to b squared plus c squared minus a squared all over 2 times b times c. Okay, this is the one that when we're looking for angles. Okay, so these are what our cosine law is. I'm going to go over the proof with you tomorrow because I'm going to do that on the board. Okay, I am hoping that you're going to trust me that this is your cosine law. We're going to prove that it's going to work tomorrow when I am back. Okay, we're going to try this example right here with our cosine law. So it says round to the nearest tenth, find the length of P to R. Okay, so P to R is right here. When I'm working on this, I'm looking for a side, so I'm going to use this top portion of my formula. Okay, I think the biggest part that is maybe tricky here is that A, B, and C squared, that might be a little tricky if you're not actually given A, B, and C on here. Okay, so why don't we, if you are a person that needs to work with A, B, and C, then you may have to rewrite, like instead of P, Q, and R, you can write A, B, C. That might be a little bit easier. But I'm technically looking for this P to R, which would be a lowercase q. Okay, this would be a lowercase q. Because this is the one I'm looking for, Q is going to be my A squared, because that's the one that I'm looking for. Okay, just kind of keep that involved there. Okay, so this is Q across from P. This is going to be lowercase p. Across from R, this is going to be lowercase r. Because Q is what I'm looking for, that's the only thing that's going to matter for me at this point. Okay, everything else, it doesn't matter which one's A, which one's B. So in my brackets, I'm going to say that this is going to be my A. Okay, we can say that this is going to be my B, and then this is going to be my C. That's how we want to work with it. So let's write this out. So my formula was, because I'm looking for side length, so Q squared is equal to B squared, which is going to be my P squared, plus my C squared, which is my R squared, minus 2 times P times R times cos of Q, which is technically cos of that A. This is how my new formula is going to write out. Now I just need to type everything that I'm looking for, or type all the pieces in so I rearrange what I have. So here I have Q squared is equal to 5 squared plus 4 squared minus 2 times 5 times 4 all times cos of 60 degrees. We're going to, once I type that all in my calculator, I'm going to get that Q squared is equal to 21. I'm not looking for Q squared though, I am looking for Q. So I'm going to square root both sides, and I'm going to get Q is equal to, I'll get 4.5825, and it's going to kind of keep going. Because this one doesn't say absolute value, it does say to the nearest tenth. So one decimal place, Q is equal to, I'll say approximately, put that dot over top, 4.6 centimeters. Perfect. That's what I'm looking for, a side length, and I can't use sine law because there is only one angle. I'm not looking for another angle, and there's no pairs that are kind of working with it that way. So this would have to work with cosine law. Now, for this one here, it says find the measure of angle S to the nearest degree. So I'm looking for this angle here. I've been given 3 sides, But because I'm looking for the angle, I'm going to use the second formula for the angles, which is up here. Okay, cos of A is equal to B squared plus C squared minus A squared all over 2 times B times C. So A is going to technically be my S here, if you want to think of it like that. Okay, because this is the angle that I'm looking for. Okay, because if I want to rewrite it here, I have cos of A is equal to B squared plus C squared minus A squared all over 2 times B times C. Now it really doesn't matter which one I label as A, which one I label as B, which one I label as A, because I'm just going to be adding them together and then in the end subtracting my A squared from the whole thing. Okay, but as long as my S is my A, that's going to be my biggest piece. So I'm going to say T is going to be like my B, just if this helps people out, and then U would be my C. So that means that this would be B. This would be a lowercase a, but it's technically lowercase s. This is technically lowercase t. And then this would be lowercase u, which would kind of just be like my c. If those a, b's, and c's are confusing you, okay, then you can just keep kind of going ahead your own thing. However, okay, this is just, you need to be making sure whatever angle you're looking for, that's what you're setting in your a in your formula. So I'm going to rewrite this. So now I actually have cos of s is equal to t squared plus u squared minus s squared. That's going to be all divided by 2 times t times u. If I'm plugging that into my formula, I get cos of s is equal to, I get 3.5 all squared plus 4 squared minus 7 squared, all divided by 2 times 3.5 times 4. I plug this into my calculator, I get cos of s is equal to, I'm going to get, does my sheet say a negative number? I get negative 0.74107. That's not what I'm looking for though. I need to inverse, okay, this cos, okay, to find out what my angle is going to be. So inverse cos of that negative 0.74. Oh, bless me, sorry. Okay, and I'm going to get a number of 137.822, kind of keeps going. So my angle of S is going to be approximately 138 degrees. We are not used to seeing anything over 90 degrees. However, this isn't a right angle triangle. Okay, this is an oblique triangle, meaning one of them will be obtuse, and this is going to be larger. Okay, that is your cosine law. Okay, I am going to leave it there. I know that there's some word problems here. I'm going to leave it that you guys are going to try to work those out. The hardest part is just like drawing out your triangle, but you need to be making sure you're drawing a picture so you have all of those pieces that are working with it. If you can pause the video here so you have these up on the board, but you do need to be making sure you write them down to work with it. And please keep in mind 20-1, like I will be here tomorrow, and you do have your trig quiz. So the substitute will be handing out a review. But again, quizzes are not worth marks. If you would like to go over something with me tomorrow morning, we can. And in the quiz, I can also help you out with that cosine law or sine law if you're needing at that point. I am going to be available through Teams message. I won't be able to message back right away. I'll just try my best, but I think you guys are going to get it. Okay, good luck.